A very warm greeting to everyone. This is Dr. Anand here, and today I'm here to talk about one of the most important analysis using the NIME platform, that is the cluster analysis using the hierarchical clustering. So to perform this particular task with me, I have an interesting data set which is very much from Kaggle, as you can see it on the screen. This particular data set, which is on employee absenteeism, is quite interesting. So let's look into the data set and the description of the data set. So this data has been collected from ABC company and it pertains to 740 employees. So you can see the total number of row count is 740 and there are 21 interesting factors. Looking into the factor, the very first one is the month of absence, the second one is the day and the week of the absent, the third one is the season of the absence. So the season has been classified into summer, autumn, winter and spring. There are few different industries or sectors which prioritizes on sector. Let me give an example for that: sugarcane manufacturing. So that is based on a seasonal employment. So of course, if the employees are absent, then it does not make any sense for that particular organization to retain them. So such type of employees who are frequently absent during a very important season where the production is more or where the demand is more, but unfortunately the supply becomes less because the production also becomes less because the employees are not able to turn up to the work because continuously they are absent, then the organization has to take a very strong decision. The fourth important factor here is the transportation expense. 99.9% of the organizations do provide employees with a non-financial benefit, which is not a part of the basic pay or the salary, which includes multiple different types of allowances like the HR allowances, the gardener allowances, the vegetable allowances, the housing allowances, and of course the transportation expense, which has been borne by the organization. So what if the employees are enjoying the transportation expense and still they are frequently absent, not taking a lot of interest to work? So that becomes one of the biggest cost for the organization, which has to be chopped. The fifth important one is the distance from the residence to work. I think in metropolitan or in cosmopolitan cities like Chennai, Bangalore, Hyderabad, Delhi, or Pune, takes a lot of trauma for the employees to reach the organization where they work on the right time. So if the employees are not able to punch in the biometric attendance, then it becomes a huge ruckus which would be created by the HR department. So distance from residence to work plays a very important role. Sixth one is the service time. Then the seventh one is age. Age of the employee also plays a very major role, which can be classified into multiple categories. Say, for example, if you take any organization, age category of employees between 25 to 35 can be considered to be the youth community, and a lot of work can be extracted or squeezed from this youth community. So probably if you take the other age group of 50 to 60, they are on the urge of reaching the category of senior citizen. So they would be having a lot of experience. They might not be technically inclined, and the management has to take a decision whether to retain such type of employees or not. So age plays a very important role. Average workload, which is also a very important factor. Few employees might be working on a single shift, but others might be working on a double shift based on the family expectations, pressure, financial expectations. So in case if an employee is working for double shift, then he might be absent on the other day, or he would like to absent himself so that he can relax at home. Hit target also plays a very important role. That is nothing but the number of hours where the employees have to work in a given particular day. Disciplinary failure, every humans do commit a lot of failures. In case if the employees has committed any failure, then it has been marked as 1, and if not, it has been marked as 0. The reason why disciplinary failure plays a very important role when it comes to the HR analytics is because during the time of performance appraisal, such type of information has to be taken care by the HR department, whether to retain the employee or whether to give a golden handshake. The 11th important one is education, 12th is number of children in a family, 13 is social drinker, social smoker, the number of pet animals, and the most interesting factor is body mass index. So there are a lot of medical reports which is very much available on the internet which very clearly says that any individual person whose body mass index is more than 30 is on the obese side. So maybe taking into consideration from the HR perspective, especially like a production department or a clerical job or a field executive or a sales representative where they have to stand for a very long time, then the body mass index plays a major role. So most of the employees with body mass index has to be clustered together so that wellness programs, medical camps, or other types of medical checkups can be done very frequently, which becomes one of the most important role from the HR perspective. So this data set, which is very much available on Kaggle in the name employee absenteeism, has been taken into account for performing the analysis on 9. So this is how the workflow looks, and this is how I have performed multiple cluster analysis. The one which you can see in the very front two lines is the cluster analysis using k-means. But in this masterclass, very exclusively, I would be talking about the hierarchical cluster. So hierarchical clustering in employee absenteeism data analysis using 9. So let's look into the learning objectives of this particular masterclass. The very first one is to understand the application of hierarchical clustering in HR analytics. So this is where we learn how to identify natural employee grouping based on behavioral factors or demographic factors, or it can also be psychographic factors using the unsupervised machine learning. So what exactly do you mean by this unsupervised machine learning? So unsupervised machine learning is a type of an algorithm that identifies pattern or structures in the data without using a labeled outcome. So this helps to discover the hidden patterns, natural grouping, which is nothing but the clusters, or the associations within a data set, especially when you have no prior target variable which is being defined. So in HR analytics, the unsupervised machine learning is used when you are exploring data to understand employee behavior or a particular segment or a particular population, or to uncover insights without predefined clusters. So when do we use predefined clusters? In the NIME platform, when we are performing the cluster analysis using the k-means, that is where we use the predefined cluster. But in case if you are going to do a cluster analysis using this particular approach, which is known as the hierarchical clustering, then we do not give importance to any predetermined cluster. So let me give you 5 importance in HR analytics with regard to the unsupervised machine learning technique. As I told you before, the first one is employee segmentation. So this would help a data scientist to group employees based on similarities. Say for example, let's take age, performance, or tenure of the employee to take some structured HR strategies. The second one is attrition risk clustering. 99.9% of the organizations across the globe are facing a lot of attrition issues, and it is very much prevalent across multiple sectors and multiple industries. So this would help the data scientist identify clusters of employees at potential risk who are in a risk of leaving or even without a prior label. The third important one, as an example, I can talk about the workforce diversity analysis. So this unsupervised machine learning technique will help you to detect the underlying diversity patterns or the basis in hiring or promotions or salary structures. So this itself would help the HR department to identify the workforce diversity in multiple angles. The fourth important one is TND, that is training and development, training needs analysis. So I think you would be knowing that it becomes mandatory for any organization to provide training and development for its employees so that they are motivated and they can be retained in the organization for a very long time. So clustering employees based on the skill or the skill gap or the performance, and then to design customized training programs will help the department, that is the HR department, for cutting down the cost and also to render the best training as per the expectations, demands, needs, wants, and desires of the employees. The fifth important example what I can talk here is about the employee engagement pattern. So a data scientist, when he's dealing with such type of employee data and when he's giving importance to the unsupervised machine learning, it would help him to identify the hidden trends in employee engagement or the feedback data. Say for example, the data which has been collected from a survey or a Google form. So this unsupervised machine learning plays a very important role, and that is why that is our second learning objective. Looking into the next one, it is to develop the data processing skills in KNIME. So as soon as you get any data on an Excel format or a .csv format, the same cannot be taken into consideration for performing multiple analysis on KNIME, because that particular data has to be cleaned, it has to be normalized, it has to be filtered, and then it has to be used in the right way by the HR department or a data scientist to perform the clustering analysis. So directly any clustering analysis cannot be performed. So a person who's using KNIME should have that ability to clean the data. So the second learning objective is to develop data pre-processing skills on the KNIME platform. Let me talk about the third important learning objective, that is to gain practical experience with distance metrics and linkage methods. Let me go a little deep into it. So first and foremost, it becomes very important to understand how to select and apply an appropriate distance measures. Let me give you an example. We do have Elucidine, we do have Manhattan, and other linkage strategies. So it can be with regard to a complete linkage strategies or an average or a summation or a word based on the variable types and the research goals. So a data scientist should first gain practical experience with distance metrics and the linkage methods. The fourth important one is to interpret the dendrograms and cluster visualizations. A data scientist should learn to visually analyze the hierarchical patterns, which is nothing but the dendrograms. Dendrograms in other simple terms can be known as a tree-like structures. So when you're performing this hierarchical clustering analysis using the KNIME platform, the output result exactly looks like a tree branch. So that would help you to group the profiles to extract meaningful insights from the cluster data. The last important learning objective is to apply the data-driven segmentation to the HR decision making. So using the clustering results to generate actionable HR recommendations such as targeted policy design or commuting support for the employees with better planned transportation facilities and infrastructure, or curating a better wellness programs and educating the employees or creating awareness to them about the importance of not being absent, will always help the organization to scale up its employee performance. So these are all the 5 important learning objectives before we start with the hierarchical clustering analysis using the KNIME platform. So now let me tell you what exactly do you mean by this hierarchical clustering in HR analytics. So cluster analysis in HR analytics is a very powerful technique for grouping the employees based on similarities and behavior, allowing the HR professionals to identify a distinct employee segment. So by uncovering the hidden pattern in HR data such as performance, engagement, turnover, this cluster analysis will help in making more informed and effective decisions. So cluster analysis, of course, is a data mining technique that would help to group the similar data points into multiple clusters as per the expectations of the data scientist. So why am I talking about different clusters? Say for example, if you want a single cluster, you can go for a single one. Or if you want to go for more than 3, you can go for more than 3. So the number of clusters which has to be taken into consideration purely depends on the person who is performing the analysis. So in HR, this means grouping the employees based on shared characteristics, which would really help the organization to segment the entire organization into multiple groups. I've already given you an example for what exactly do you mean by this unsupervised machine learning technique. So since I've highlighted, it's a very important factor which has to be taken into consideration. So let me give you the meaning again. An unsupervised machine learning technique is a type of an algorithm that helps to identify the pattern or structures in a data without using any labeled outcomes. So this would help to discover hidden patterns, natural grouping, or find the association within the given data set. So now let's look into the NIME platform. So NIME workflow is very important, and NIME is where we are going to perform the analysis. A NIME workflow is a visual drag and drop pipeline that represents a series of data processing steps from data input to data transformation to data analysis and data output. So all is done using a series of multiple nodes. Each node performs a specific function. So let me give you examples for multiple functions here. Reading the data file is a function. Filtering the data using a filtering a row option is a function. Clustering is a function. Visualization is a function. So the functions can be chosen as per the analysis and expectations of a given module or a particular project. And node would also help a data scientist to establish connection between multiple nodes to ensure that the flow of data is there throughout the entire process. So now let me talk about the features of a NIME workflow. First one is a visual and modular. It is built by connecting multiple nodes and multiple blocks. As you can see on this particular screen, it's a visual representation where multiple nodes are interlinked with each other so that there is a flow of data throughout the entire process. Second one, no coding is needed. So NIME is exclusively designed for users with minimal programming skills. So you just have to use the drag and drop option to use multiple nodes and to perform the task what you want to do. The third important one, it is very much interactive because you can inspect the data at each step. The fourth important one is reusable. Workflows can be saved, it can be modified, it can be reused for different data set. The last important one is extensible. So when I'm talking about extensible, it integrates with Python, R, SQL, and ML libraries. So these are all the very basic features of a NIME workflow. Now let me talk about the basic structure. So what are all the different types of nodes which is very much needed here? Input node. The second one is the pre-processing node. When we are talking about the pre-processing node, the nodes related to cleaning, filtering, missing values, or handling the data. The third important one, node function, is transformation nodes for scaling up or for encoding, feature engineering. The fourth important one is modeling nodes to apply the machine learning algorithm like clustering, decision trees, random forest. The fifth important one, of course, to visualize the data. Multiple graphs can be used, multiple charts can be used like the dendrogram diagrams or the bar charts. The last important one is the output node. So in the output node, we can export the results to a file or to a particular dashboard. So these are all the multiple different types of basic nodes which is very much used on the NIME platform. Let me give you a summary of it. The input node, the pre-processing nodes, transformation nodes, modeling nodes, visualization nodes, and the output nodes. So now, before starting with this analysis, let me tell you what are all the different types of data which I have taken into consideration. First, using an Excel reader, the data has been imported and you can also see the data set here. So probably if you look into the data set has been taken from Kaggle. You can see 740 columns here, and the data has been classified under 21 factors in 21 rows. So these are all the same factors what we had discussed much before. It starts with the row ID, age, education, ID number, reasons for being absent, month of being absent, day of being absent, season, transport expenses, distance, service time, workload, hit target, discipline, number of children, social drinker, social smoker, number of pet animals. weight, height, body mass index, and number of days where the employees were absent. So these are all the data or the information pertaining to this particular raw data which we have taken into consideration. So now I have used a column filter node, a column filter legacy node. So as you can see, the column filter legacy node in KNIME is used to select only the relevant variables for analysis while excluding the unwanted factors or the noisy data columns. So this particular dialog box has the exclusion box and the inclusion box, and very much in the inclusion box I've taken into consideration only two important factors, that is age and transportation expense. Age of the employees, which is starting from 25 and it ends with 60. So that is the information what we get to see from the data set. The second important one is transportation expense. As I've told you before, 99.9% of the organizations across multiple sectors and industries are supporting the employees by providing the transportation expense. If you look into this particular data set, what we have, the transportation expense is starting from 150 rupees probably, and then it goes till 500 rupees. So what if a group of employees are getting the transportation expenses from the organization but still keeping themselves absent for a couple of days, which is going to create a huge ruckus in the production department. And of course, it is going to affect the brandwill and the goodwill of the organization. So the HR department has to take a very crucial decision whether to retain such type of employees or to get rid away from them. So the transportation expense also plays a very important role, and that is why we have taken these two important variables here. So as you can see in this particular screenshot, in the include panel, which is in green color, only age and transportation expenses are selected. So other variables such as disciplinary failure, weight, social drinker are all excluded, the ones which you can see in this particular red box. So a manual selection is used to ensure the precise control over which columns are passed into the clustering model. So once after you choose the important factors into your inclusion box, you just have to click apply and OK, and then you have to execute this particular node. I've already executed. You have to right click and execute. So once if you execute, the color from this particular node moves from yellow to green, which means that the data file has been successfully executed. So let me also give you a few more information with regard to the column filter node. So this particular node ensures that only two intended variables are used in the distance calculation and clustering process. So this becomes very crucial because including irrelevant or high dimensional categorical variables such as social habits or family data, it could distort the clustering output. So the column filter node was configured to include only the numeric variables, that is age and transportation expenses. So this ensures that the clustering model is more focused strictly on the demographic and the logistical absenteeism factor. All the non-essential or categorical variables has been excluded to prevent the noise and to ensure dimensional relevance in distance-based clustering. I hope you are clear now with this particular node, which is a column filter node. The second important one here, let me talk about the missing value node. See, clustering algorithms like hierarchical clustering cannot handle the missing values. So what exactly do you mean by the missing values? Which is null, or it has a blank cell, or it is left untreated, or it has a lot of question marks. So this can cause errors or fail the execution process, or it might create a lot of issues when the distance is being calculated. We can also take into consideration that it creates a lot of distort clustering patterns if imputed incorrectly or if the missing values are ignored. So that is why it becomes very important to very gently handle the data where this missing value node has to be prioritized. The role of missing value node in 9. So what exactly do you mean by the name of this particular node? It is called the missing value node. As I told you before, there is a single purpose for this particular node: to detect, to process, and to handle the missing data in any data column before the clustering or the analytics takes place. So how do you have to do this particular setting? You just have to connect the nodes together. You just have to right click and you have to look into this particular dialog box. So if you look into this particular dialog box, there are multiple options here. So you can replace with mean, median, or mode, say for example, for numeric variables like age or transport expenses. Or you can also replace the same with a constant. So what exactly do you mean by a constant, such as a 0 or unknown? Or you can remove that entire row. If missing values are very minimal, the entire row can be removed. Or you can also apply the column wise imputation where it is based on the data type and the pattern. So multiple things can be done, but however, I have given importance to remove the entire row. The third important one is the normalizer node. So what exactly do you mean by this? Normalization method, it starts with minimum max, which is on the default. The column normalized. The columns are normalized. So what is normalized here? Age is normalized and transportation expenses are normalized. Let me give you a little more elaborate information pertaining to the normalizer mode. Since age and transportation expenses are on different scale, this node brings them to a uniform range. Say for example, 0 to 1. So this is essential to prevent variables with larger numerical ranges from being disappropriately influencing the clustering outcome. So that is why we use this particular normalizer mode. So nothing has to be done here. You just have to right click and execute this particular node. The next we have the distance matrix calculation node. So what is the dialog setting here? Distance measure chosen here is Manhattan distance. And probably if you look into the columns used, it is a normalized age, normalized transport expense, which has been taken into consideration. So the Manhattan distance is suitable for mixed type of data, particularly when we are including binary variables. So this node will compute the pairwise distance between each employees based on 3 chosen attributes. So that is why we have used this particular function. Then we have the hierarchical clustering distance matrix node. So if you look into the dialog setting, it has the linkage type is average linkage and the distance matrix source is output from the previous node. You can see the node connection. So this node builds a hierarchical structure tree based on the distance matrix, linking the most similar employee records and progressively merging them until a single hierarchy is formed. So average linking is selected for its balanced treatment of distance spread, ensuring moderate cluster are created as per the expectations of this particular analysis. Then we also have hierarchical cluster JavaScript node, right? Hierarchical cluster. We also have the JavaScript node. So what is this about? The number of clusters assigned is very much 3, that is based on the dendrogram. So this converts the tree structures into actionable groups, each representing a unique employee profile based on the absenteeism related trait. And we do have one more node, that is the cluster assigner. We also have the hierarchical clustering node here, as you can see. So this allows an interactive visualization for the dendrogram. You can also have zoom and node selection features. So this node visually represents how clusters form over stages. The dendrogram helps to determine the optimal number of clusters by identifying natural cuts where the branch length are the longest, indicating a very greater dissimilarity. So these are all the multiple nodes which we have very much used in this particular mechanism. So let me also tell you again that it becomes very important for a data scientist to first know about the data set. What are all the different types of factors associated with the data set? The third important one, how the data set can be used with multiple purpose. The fourth important one is how to relook into the data set to understand and to come out with multiple decisions. Certain technical or technological terms also has to be taken into consideration. So before performing the hierarchical structure, we really have to know about what exactly do you mean by this distance measures. See, each method defines how different two data points are. Say for example, if you take this distance function, each approach is different. So what do you mean by this Euclidean distance? Euclidean definition means it is a straight line distance between 2 points in n-dimensional space. So when your data is numeric or on similar scales, this particular approach has to be used. I'll give you an example. Age and absenteeism hours or expenses is a numeric data, right? But in case of Manhattan, we use mixed data. It can be numeric. Sometimes it might be non-numeric also, which might be converted. Say for example, let's take occupation. Occupation is not a numeric data. So when we are dealing with non-numeric data, a Manhattan approach can be used. I'll give you an example for this Euclidean distance. If employee A, say for example, name of employee A is called employee Anand. Employee Anand has been absent 5 absent hours and employee B has been absent for 8 hours. Then the Euclidean distance would reflect a straight numeric difference in multi-variable space. So that is why we have to know what type of variables we have, what is the attribute of that particular variable, and then accordingly we have to take into consideration. So likewise, there are multiple other approaches which can be taken into consideration while we are performing in this particular 9 platform. Say for example, we do have the Tanimoto coefficient, we have the cosine similarity, there is a bivector cosine, we also have the other types of approaches here, other types of distance functions here. But one of the most important distance function what I have taken into consideration in this particular explanation is the Euclidean, and I've also given you the meaning or the explanation and the justification why I am taking into consideration this Euclidean, because very clearly I've told you that age and transportation expenses both are very much expressed in the numeric terms, right? It is not a variable which is non-numeric. So I hope this particular explanation was very much clear. Now let us look into the analysis and further in the other upcoming video. Thank you.